In this video, you're going to learn how to connect your Node applications to the MongoDB database that you have running on your local machine. This means that we'll be able to issue database commands right inside of our Node apps to do stuff like insert, update, delete, or read data. This is going to be critical if we're ever going to make that to-do REST API. When someone hits one of our API endpoints, we want to manipulate the database, whether it's reading all of the to-dos or adding a new one. Before we can do any of that, though, we have to learn the basics. To connect to our MongoDB database from inside of Node.js, we're going to be using an NPM module created by the MongoDB team. It's called Node MongoDB Native, and it includes all of the features you'll need to connect to and interact with your database. To get to it, we're going to Google Node MongoDB Native. The GitHub repo, which should be the first link, is the one we want, the Node MongoDB Native repository. And if we scroll down, we can take a look at a few important links. First up, we have documentation, and we also have our API docs. These are going to be critical as we start exploring the features that we have inside of this library. Down below, there's a ton of examples on how to get started. We'll be going through a lot of this stuff in this course, but I do want to make you aware where you can find other resources because the MongoDB native library has a ton of features. There are entire courses dedicated just to MongoDB, and they don't even begin to cover everything that's built into this library. We're going to be focusing on the important and common subset of MongoDB that we need for Node.js apps. To get started, let's go ahead and open up the docs. When you go to the docs page, you do have to pick your version. We'll be using version 2.2 of the driver, and there's two important links here. We have a reference link. This includes guide-like articles, things to get you started, and other various references. If you go back and you go to the API link, this includes the details of every single method available to you when you're working with the library. And we'll be exploring some of the methods in here as we get started creating our Node to-do API. For now, though, we can get started by creating a new directory for this project, and then we're going to go ahead and install the MongoDB library and connect to the database we have running. Now, I am going to assume that you have your database running for all of the videos in this section. I have it running in a separate tab in my terminal. It's sitting right here. If you're on Windows, refer to the instructions in the Windows install video to start your database if you forget. If you're on the Linux or OS X operating systems, use those instructions. And don't forget to also include that DB path argument. That is essential for booting up your MongoDB server. To kick things off, I'm going to make a new folder on the desktop for the Node API. I'll use mkdir to create a new directory called node-to-do-api. And then I can go ahead and use cd to go into that directory. cd node to do API. And from here, we're going to run npm init, which creates our package.json file and lets us install this MongoDB library. npm init. Once again, like we've done throughout the course, we're going to be using enter to skip through all of the options using the defaults for each. Once we get to the end, we can confirm, and now our package.json file is created. The next thing we're going to do is open up this directory inside of Atom. I'm going to go ahead and pop that open real quick. It's on the desktop, and here it is, Node to do API. Next up, inside of the root of the project, we're going to create a new folder, and I'm going to call this folder Playground. Inside of here, we'll store various scripts. They're not going to be scripts related to the To-Do API. They'll be scripts related to MongoDB. So I do want to keep them in the folder, but I don't necessarily want them to be part of the app. We'll use the Playground folder for that like we have in the past. In the Playground folder, let's go ahead and make a new file, and we'll call this file MongoDB connect.js. Inside of this file, we're going to get started by loading in the library and connecting to the database. Now, in order to do that, we do have to install the library. From the terminal, we can run npm install to get that done. npm install. The library name is MongoDB, all lowercase, no hyphens. Then we're going to go ahead and specify the version to make sure we're all using the same functionality at 2.2.5. This is the most recent version as of the filming. After the version number, I am going to use the save flag. This is going to save it as a regular dependency, which it is. We're going to need this to run the To-Do API application. With MongoDB now installed, we can move in to our MongoDB connect file and start connecting to the database. The first thing we need to do is pull something out of the library that we just installed, that MongoDB library. What we're looking for is what's called the Mongo client. The Mongo client lets you connect to a Mongo server and issue commands to manipulate the database. Let's go ahead and kick things off by creating a constant called uppercase M Mongo client. And we're going to set that equal to require, and we're going to require the library we just installed, MongoDB. And from that library, we're going to pull off Mongo client, just like this. Excellent. With the Mongo client now in place, we can call Mongo client.connect to connect to the database. Mongo client.connect. And this is a method and it takes two arguments. The first argument is a string, and this is going to be the URL where your database lives. Now, in a production example, this might be an Amazon Web Services URL or a Heroku URL. For our case, it's going to be that localhost URL. We'll talk about that in just a second. The second argument, that is going to be a callback function. The callback function will fire after the connection has either succeeded or failed, and then we can go ahead and handle things appropriately. If the connection failed, we'll print a message and stop the program. If it succeeded, we can start manipulating the database. That first argument, in our case, is going to look something like this. We're going to start it off with MongoDB : //. When we connect to a MongoDB database, we want to use the MongoDB protocol like this. Next up, it's going to be at localhost since we're running it on our local machine. And we have the port, which we already explored, 27017. After the port, we need to use / to specify which database we want to connect to. Now, in the last video, we used that test database. This is the default database that MongoDB gives you, but we could go ahead and create a new one. After the /, I'm going to call the database to-do app just like this. Next up, we can go ahead and provide that callback function. I'm going to use an ES6 arrow function, and we're going to get past two arguments. The first one is going to be an error argument. This may or may not exist. Just like we've seen in the past, it'll exist if an error actually happened, otherwise it won't. The second argument is going to be the DB object. This is what we can use to issue commands to read and write data. Now, before we write any data, I'm going to go ahead and handle any potential errors that come about. I'll do that using an if statement, if error. If there is an error, we're going to print a message to the console, letting whoever is looking at the logs know that we were unable to connect to the database server. Console.log. Then inside of quotes, something like unable to connect to MongoDB server. Excellent. After the if statement, we can go ahead and log out a success message, something like console.log. Then inside of quotes, we'll use connected to MongoDB server. Now, when you're handling errors like this, the success code is going to run even if the error block runs. What we want to do instead is add a return statement right here. This return statement isn't doing anything fancy. All we're doing is using it to prevent the rest of the function from executing. As soon as you return from a function, the program stops, which means if an error does occur, the message will get logged, the function will stop, and we'll never see this connected to MongoDB server message. The alternative from the return keyword would be to add an else clause like this and put our success code in here, but it's unnecessary. We can just use this syntax, which I prefer. Now, before we run this file, there is one more thing I want to do. At the very bottom of our callback function, we're going to call a method on DB. It's db.close. This closes the connection with the MongoDB server. Now that we have this in place, we can actually save the MongoDB connect file and run it over inside of the terminal. It doesn't do much yet, but it is indeed going to work. Over in the terminal, we can run it using node. Playground is the directory, and the file itself is mongodb-connect.js. When we run this file, what do? We get connected to MongoDB server printing to the screen. And if we head over into the tab where we have the MongoDB server, we can see we got a new connection accepted, and then that connection was closed down below. And this is fantastic. Using the Mongo library, we were able to connect, print a message, and disconnect from the server. Now you might have noticed that we changed the database name right here, and we never actually did anything to create it. In MongoDB, unlike other database programs, you don't need to create a database before you start using it. If I want to kick up a new database, I simply give it a name, something like users. Now I have a users database, I can connect to it and I can manipulate it. There is no need to create that database first. I'm going to go ahead and change this back to To-Do app. And if we head into the Robo Mongo program and connect to our local database, you'll also see that the only database we have here is test. The To-Do app database was never even created, even though we connected to it. Mongo is not going to create the database until we start adding data into it. And we can go ahead and do that right now. Inside of Atom, what we're going to do right before our call to db.close is insert a new record into a collection. Now this is going to be the To-Do application. We're going to have two collections in this app, a To-Dos collection and a Users collection. Right here, we can go ahead and start adding some data to the To-Dos collection by calling db.collection. db.collection takes as its only argument the string name for the collection you want to insert into. Now, like the actual database itself, you don't need to create this collection first. You can simply give it a name, like uppercase T To-Dos, and you can start inserting into it. There is no need to run any command to create it. Right here, we're going to use a method available on our collection called insert1. Insert1 lets you insert a new document into your collection. It takes two arguments. The first one is going to be an object. This is going to store the various key value pairs we want to have on our document. The second one is going to be a callback function. This callback function will get fired when things either fail or go well. You're going to get an error argument, which may or may not exist, and you'll also get the result argument, which is going to be provided if things went well. Inside of the arrow callback function itself, we can add some code to handle the error, and then we'll add some code to print the object to the screen if it was added successfully. First up, let's add that error handler. Much like we do above, we're going to check if the error argument exists. If it does, then we'll simply print a message using the return keyword to stop the function execution. Here, we can use console.log to print unable to insert to do. Excellent. The second argument I'm going to pass to console.log is going to be the actual error object itself. So if someone's looking at the logs, they can see exactly what went wrong. Down below our if statement, we can add our success code. In this case, all we're going to do is pretty print something to the screen. Console.log, and then I'm going to call JSON.stringify. And then we're going to go ahead and pass in result.ops. The ops attribute is going to store all of the docs that were inserted. In this case, we used insert1, so it's just going to be our one document. And then I can add my other two arguments undefined for the filter function, and the indentation will be 2. With this in place, we can now go ahead and execute our file and see what happens. Hey, it's Andrew from the future with a quick update. This course was filmed using MongoDB module v2, and the code for that is the code that we just wrote out in the video. I've put it over here just for comparison's sake. This code right here is the exact code that you have in your file. Now, if you're using MongoDB module v2, you can stick with this code. The code is going to work as expected. You can figure out what version of MongoDB you installed by looking for it in package.json. Now, some students have upgraded to v3, and you can't just make the upgrade with the same code because there are a few API changes that we're going to need to address. So on the left-hand side, we have the current code. On the right-hand side, we have the updated code. There are 3 things we're going to talk about. We're going to talk about a change in arguments. We're going to talk about a new line, and we're going to talk about a change in where we access the close method. So first up, the arguments. No longer do we get error and DB, we now get error and client in v3. So we have to use this client argument instead. Now we do still need access to a database reference. We get that with this new line. Here we use client.db, calling it, passing in the database reference we're looking for. In this case, we're trying to get a reference for the To-Do app database. Then we have this db, and we can actually do something meaningful with it, like call db.collection. So all of the code here hasn't changed at all. It's the exact same code over here. All that changes is that we now need to do a bit of work to get that database reference. So that's the argument change and the new line change. The last thing to talk about is that there is no longer a db.close method. It is now client.close. So you're going to want to make sure to change that as well. If you looked in package.json and you're using v2 of MongoDB, you don't have to make a single change. If you do see yourself using v3, you're going to have to make those 3 changes before running the script. All right, that is it for this update. Everything else is exactly the same. Let's jump right back into the video. Over inside of the terminal, I'm going to run node playground / MongoDB -connect.js. When I execute the command, we get our success message connected to MongoDB server. Then we get an array of documents that were inserted. Now, as I mentioned, in this case, we just inserted one document and that shows up right here. We have the text property. The text property gets created by us. We have the completed property that gets created by us. And we have the _ID property, which gets automatically added by Mongo. Now, the _ID property is going to be the topic of the next video. We're going to talk in depth about what it is, why it exists, and why it's awesome. For now, we're going to go ahead and just know that it's a unique identifier. It's an ID given to just this document. And there we go. That is all it takes to insert a document into your MongoDB database using Node.js. We can view this doc over inside of RoboMongo. Up here, I'm going to click the connection using right click and click refresh. This reveals our brand new to-do app database. If we open that up, we get our collections list. We can then go into the collections, view the documents, and what do we get? We get our one to-do item. If we expand it, we can see we have our ID, we have our text property, and we have our completed Boolean. In this case, the to-do is not completed, so the completed value is false. Now that we have this in place, what I want you to do is add a new record into a collection. This is going to be your challenge for the video. Over inside of Atom, what I'd like you to do is take the code all the way from db.collection down to the bottom of our callback and comment it out. Then we're going to go ahead and add something down below. Right here, you're going to insert new doc into the users collection, uppercase U users. This doc is going to have a few properties. I want you to give it a name property, set that equal to your name. Then we're going to give it an age property. And last but not least, we can give it a location string. I want you to insert that doc using insert1. You're going to need to pass in the new collection name into the collection method. Then down below, you're going to add some error handling code and you're going to print the ops to the screen. Once you rerun the file, you should be able to view your record in the terminal and you should be able to refresh things over in RoboMongo. You should see the new users collection and you should see your user with the name, age, and location you specified right here. So take a moment to pause the video, create that new record, check that it works by viewing it in the terminal and in RoboMongo, and when you're done, go ahead and click play. How'd you do? Hopefully you were able to insert a new document into that users collection. What you needed to do in order to get this done is call db.collection so we can access the collection we want to insert into, which in this case is users. Next up, we have to call a method to manipulate that users collection. We want to insert a new document, so we're going to use insert1 just like we did up above. We're going to pass into insert1 our 2 arguments. The first one is the document to insert. We're going to give it a name property. I'll set that equal to Andrew. And then we can go ahead and set the age equal to something like 25. And lastly, we'll set location equal to my current location, Philadelphia. Excellent. The next argument we wanted to pass in is our callback function, which is going to get called with the error object as well as the result. Inside of the callback function itself, we're going to first handle the error. If there was an error, we're going to go ahead and log it to the screen. I'm going to return console.log, and then we can put a message right here, unable to insert user. Then I'll add the error argument as the second argument to console.log. Next up, down below, we can add our success case code. If things do go well, all I'm going to do is use console.log to print result.ops to the screen. this is going to show us all of the records that were inserted. With this in place, we can now go ahead and rerun the file over inside of the terminal using the up arrow key and the enter key. When we do it, what do we get? We get our array of inserted documents, and we just have one. The name, age, and location all come from us, and the ID property comes from MongoDB. Next up, I wanted you to verify that it was indeed inserted by viewing it over in RoboMongo. In general, when you add a new collection or a new database, you can just right-click the connection itself, click refresh, and then you should be able to see everything that was added. Right here, we have our users collection. I can view the documents for users, and what do we get? We get our one document with name set to Andrew, age set to 25, and location set to Philadelphia. With this in place, we are now done. We've been able to connect to our MongoDB database using Node.js, and we've also learned how to insert documents using this Mongo native library. With this in place, we're now ready to move on to the next video, where we're going to take an in-depth look at object IDs, exploring exactly what they are and why they're useful. Stay tuned. I will see you next time.